Hello everyone, welcome to another session in fluid mechanics and hydraulic machines. Myself Dr. Padala Rajshekhar, Assistant Professor, Department of Civil Engineering and School of Engineering, SR University. So this is another lecture in our fluid mechanics and hydraulics. So we'll see the recap of the previous lecture. Just we will look into the recap, then we will go to today's content. So we have seen Pascal's law states that pressure applied at any point in a confined fluid is transmitted equally in all directions. Applications include hydraulic lifts, pressure and braking systems. That also we have seen, and absolute pressure, gauge pressure, atmospheric pressure, these all things we have seen. Absolute pressure is calculated by adding gauge pressure or subtracting vacuum pressure from atmospheric pressure depending on the conditions. So solve problems to calculate absolute pressure using the barometric readings and pressure intensity. Discussed pressure measurement methods using manometers and mechanical gauges. That also we have done. So measurement of pressure. Here manometers are devices used to measure fluid pressure by balancing the fluid column with another fluid, often a manometric liquid like mercury or water. So in this thing we are using maybe mercury or maybe water, but one is at closed, one is at open, that is called simple manometer. These measures simple manometer the pressure at a single point in a fluid, usually in a pipe or a container. You see, this is a pipe measuring the fluid, this we can see, and this is open to the atmosphere, and one end is connected to the fluid, that is this one, and the other is open to the atmosphere. So other is open to the atmosphere. So here another one is called piezometer. So piezometer means so a simple vertical glass tube inserted directly into the pipe or a tank. That means you can consider here there is a kind of tank. So if we want to measure the water level inside the tank, it is very difficult. So these things will make you simplified. Piezometer is nothing but a simple vertical glass tube inserted directly into the pipe. So you see here there is a tank and there is a pipe connected, that is called piezometer tube. So there we can get the level of water simply. Now we will see another one is called piezometers are not useful for measuring large pressures in light liquids. So like water, because they would need very tall tubes which are hard to handle. So piezometers this also piezometers cannot measure glass pressure because glasses gases does not form any visible surface. So that is one major thing. So next they went with respect to these problems are solved by using YouTube manometer. So here there is a YouTube manometer which you can see, one is positive measure and negative measure, both can be measured. A YouTube manometer consists of glass tube bent in U-shaped, one end of which is connected to the page and other end remains open. Next one, in a YouTube manometer where pressure changes, the liquid rises in one side and falls in other side. A single manometer is a modified form of a U-tube manometer in which a shallow reservoir having a large cross-sectional area as compared to the area of the tube. Now you see this all things will be U-tube manometer having some issues, that is inconvenient bit. So again they went with respect to some kind of reservoir. So you can see they are telling a modified version having a shallow reservoir. But here you can see there will be like reducing in water or increasing in water. So, but here also H1, H2 we can find. See X bar, Y bar, both are there. Now coming to the another one, differential manometers. So differential manometers like two piezometer manometer and inverted U-tube manometer and U-tube differential manometer and micro manometer are there. Now we will see one by one. So type 2 piezometer manometer and inverted U-tube manometer and U-tube differential manometer and micro manometer. That means two vertical tubes, that is nothing but piezometers, inserted at two pressure points. That means difference in liquid height gives pressure difference. That is suitable for low pressure differences in liquids. And inverted U-tube is also suitable for low pressure discharges in gases. But you see, U-shaped tube held inverted, compressed air balances liquid columns from pressure points. And U-tube differential manometer, U-shaped tube with liquid usually heavy between 2 points. Liquid levels vary with pressure differences. So moderate pressure difference in liquids and gases. And micromanometer is nothing but a precise form of U-tube manometer with enlarged ends and inclined tubes for high sensitivity. Very small pressure differences. Now you see one by one, it is used for low pressure difference, it is used for, this is particularly for liquids, this is particularly for gases, and this is moderate pressure for both liquid and gases, and very small pressure differences that you have to go in a accurate way. A precise form of U-tube manometer with enlarged ends and inclined tubes for high sensitivity. This is only for sensitivity. This is going with liquids and gases for moderate. You see U-tube U-shaped tube with liquid usually heavy between 2 points. Liquid levels vary with pressure difference. And you can see U-shaped tube held inverted, compressed air balances liquid columns from pressure points. So they are inverted but compressed air balance liquid columns from pressure points. This one is two vertical tubes, that is piezometers, inserted at two pressure points. Difference in liquid heights gives pressure difference. Now another one coming to the mechanical gauges. So mechanical gauges is nothing but bowed down tube gauge and diaphragm pressure gauge. So by bow down tube gauge, diaphragm pressure gauge and bellows pressure gauge and deadweight pressure gauge. and first one, Bowden tube gauge, diaphragm pressure gauge, and bellows pressure gauge, and deadweight pressure gauge. Now we'll see one by one type. Bowden pressure gauge is nothing but, you see, this is one. A curved hollow tube straightens when pressure is applied, moving a pointer. Here pointer is there. It's cross sectional position of the end of tube when under pressure. Pressure inlet. So if pressure is there, it will be automatically recorded. A curved hollow tube straightens when the pressure is applied moving to a pointer, and it will tell directly. And diaphragm pressure, where is diaphragm pressure? Here, the diaphragm pressure. A thin diaphragm deflects under pressure. See, here is a diaphragm, so it will deflect under pressure. Movement operates a pointer. And bellows pressure gauge is nothing but, a bellows expands, contracts with pressure, driving a gear linked pointer. So a bellows expands, contracts. Where is bellows? This one. This is a bellows pressure. You see, they will expand. That means they will expand, or they will get contrast. With contracts with pressure, driving a gear linked pointer. And deadweight pressure gauge. Known weights apply pressure to a piston used to balance fluid pressure. So they are known weights apply pressure to a piston used to balance fluid pressure. Now you see, this is deadweight pressure gauge. So a deadweight pressure gauge is used calibration, and deadweight pressure gauge used for measuring pressure at point. So this is a one kind of things where you will get directly with respect to some kind of values. So just have a quiz and we will see our performance. Which gauge uses weights to measure pressure? Bellows, deadweight pressure gauge, at Bowden's tube gauge, a diaphragm. So mark your answer. So now again I am telling, take your time. Which gauge uses weights to measure pressure? You can see. Okay. Next, which manometer is best suited for low differential pressure measures? There are two things I discussed earlier. Low pressure differentials in liquids, gases. In liquid means it is 2 piezometer, inverted U2 manometer. So they are telling best suited which one? Low differential pressure. The U2 differential manometer is mainly used to measure absolute pressure, vacuum pressure, small pressure changes, and pressure difference between 2 points. That is also important. Try to answer it. What does Pascal's law says? Pressure goes only upward. Pressure spreads equally in all directions. Pressure increases only at the bottom. Pressure stays only at one point. So try to answer it, read it. Pressure goes only upward. Pressure spreads equally in all directions. Pressure increases only at the bottom. Pressure stays only at the one point. Try to answer. So now we'll go for answers. Which gauge uses weights to measure pressure means dead weight pressure gauge. You see here clearly we are mentioning weights, right? Dead weight pressure gauge. Next one. Which manometer is best suited for low differential pressures? This is low differential pressures in liquids or gases. So you have to go with 2 piezometers. The U-tube differential manometer is mainly used to measure pressure difference between 2 points. That is what here mentioned. What does Pascal's do? Pascal's law do? Pressure spreads equally in all directions. See, this is 2 piezometers. Here I have mentioned wrongly. That is D, 2 piezometers. That's it. So if you are able to understand my lecture, so you can able to answer it. So one problem we will see. Read it. Try to understand the problem. A U-tube manometer is used to measure the pressure of oil of specific gravity 0.85 flowing in a pipeline. So they are telling 0.85. You can see here they have mentioned 0.85. Its left end is connected to a pipe and the right limb is open to the atmosphere. See, this is left limb is with respect to the pipe and right limb is with respect to the atmosphere. The center of the pipe is 100. So here to here the distance is 100 mm. It should be in mm. Below the level of mercury, that is 13.36. That is below the level of mercury. Yeah. Here they are telling this thing H1 and this is H2. The center of the pipe is 100 mm below the level of mercury in the right limb, and if the difference of the mercury levels in the two limbs is 160, determine the pressure of the oil in the pipe. So two limbs. This is one limb. This is one limb. If you are taking, see, you can see here clearly. This is a mercury, and this is liquid. So here clearly you observe there is a pipe. What is with respect to pipe? Another one with respect to open atmosphere, and they have given H1 and H2, and the left side is called liquid and right side is called mercury, and we can see the difference between if the difference between two limbs is nothing but 160. So up one is center of the pipe is 100 mm. I will try to solve this thing. Now they have given specific gravity of oil is 0.85. Specific gravity of mercury is 13.6 as we know. See here, oil means that one liquid thing. Now difference in mercury levels, that is H2 is 160, and height of the oil in the left limb is nothing but H1 is equal to 160 minus 100. Now you can see here 160 and 100, and we know that P is equal to rho GH, right? Before going to that, total pressure in the left limb equal to PA. This is PA. So that is PA plus rho naught. Rho naught means with respect to oil. One is with respect to oil, one is with respect to mercury. So PA, because why PA means in this perspective we have pressure plus rho GH in left side, because it is in a closed one, that is called pipe, whereas we can see right limb it is open to the atmosphere, so we can go with rho GH. So now you see PA plus rho naught GH1, that is called PA plus 0.85 into 1000 into 9.81 into H1 is nothing but already we have seen 160 minus 100, that is 60. So PA plus 500.31. So here the total pressure in the right limb equal to 13.6 into 1000 into 9.81 into 0.16. That is with respect to right limb, which is open to the atmosphere. Clearly you observe. And equating the pressure above the datum. Hence, PA plus 500.31. PA plus 500.31 is equal to 21346.56. So therefore, pressure at A is equal to 20,846. That is equal to 20.846 kilonewton per meter square. Once again you see, so specific first two times of things are given. One is oil and one is with respect to mercury. So both we know that. So we have to find the pressure in a simple sense. So always remember, pressure and velocity are inversely proportional. When fluid velocity, when fluid velocity increases, the pressure decreases, and vice versa, assuming other factors like density and height remains constant. That is the basic thing. When velocity increases, pressure decreases. That means I'll tell you, according to the Bernoulli's equation, P plus half rho V square plus rho GH. That is what here we are using. So once again you can see this problem. And one more similar problem we'll see. A simple U-tube manometer containing mercury is connected to a pipe in to a pipe in which the fluid specific gravity is 0.8. So fluid specific gravity is 0.8 and having vacuum pressure is flowing. The other end of the manometer is open to the atmosphere. Yes, obviously. 1, 2. Other end is open to the other. Find the vacuum pressure. Vacuum pressure in the pipe. So previously you can see there is a axis called x axis. So here liquid oil is there. Here mercury. They are satisfying the criteria of x axis. And if the difference of the mercury level in the two limbs is 40 centimeters, so here difference it went a little high, that is dominated. Mercury went to its region of the fluid in the left limb from the center of the pipe is 15 centimeters below. Just we will see the problem how to solve this thing. The specific gravity of fluid is 0.8, agree, and mercury is 13.6, agree. And here you consider this has H2, this one as H1, because there is no other option. So H1 is always left limb. So left limb H1, H2 we got. And we know the standard one, P is equal to rho GH. Now total pressure in the left limb equal to PA plus rho GH in terms of fluid and plus mercury. See, already this is a left limb. So this much area, 40 centimeters of area it conquered. So that means you have to include both. Then there won't be, see, already this is axis. After this nothing is there. You can see above axis, right limb. So everything is covered with respect to left limb. See, if you are telling this is a neutral part, assume this is a neutral part. Here 160, 100 means you can tell this is 60, this is 100 mercury, that's it. And assume this is a neutral part and there is 0. Here there is a 0 and there is a 40 and 6, 40 and 15. So here PA plus 0.8 into 1000 into 9.81 into 15, that is H1. 13.8 into 1000 into 9.81 into 40, that is H2. So PA equal to this much. Now we know there won't be anything called in right limb, 0. Equating the pressure above the datum, hence PA equal to PA plus 54543.6 equal to 0. Therefore PA equal to minus 54543.6 newtons per meter square. What is negative? Negative is nothing but vacuum. That is what they are telling. Find vacuum pressure. So find vacuum pressure in the pipe. So in the pipe we have to find vacuum pressure. Next problem. Now they have given two scenarios, two things. A differential manometer connected at the points A and B in a pipe containing an oil of specific gravity 0.9 shows a difference in mercury levels. So at 150 mm, find the difference in pressure at 2 points. So A and B they have given, one is liquid A1, another one is liquid 2. So here you see this is axis. Now you see the difference. Here mercury, this is called mercury or heavy. This should be the neutral one, but it has overtaken. Let us find. Given differential manometer connecting same line in a pipe between A and B, the specific gravity of oil, that is S0, equal to 0.9. So already they have told there will be a specific gravity of oil and specific like mercury also. So specific gravity of oil 0.9 and mercury levels 0.15, because you see here this they are telling the mercury level is 0.5. Difference in the mercury level. So assume this is a difference in the mercury level is 0.15 and 13.6 is a specific gravity, and there is a simple equation called Pa minus Pb. Pa minus Pb equal to G into H into rho g minus rho 1. Already we know this thing, and rho g h, right? Rho g h. So rho g is constant, gh is constant. Only rho we have rewritten as rho g minus 1. That we will see. Rho 1 is nothing but 0.9 into 1000. Rho g is nothing but 13.6 into 1000. Why rho 1, rho g we have taken? Because it has overtaken this area. It has overtaken this area. That is what we got, 13.6 into 1000, and this is 0.9 into 1000. That is equal to Pa minus Pb equal to 9.81 into 0.15 into 13,600 minus 900. Therefore, Pa minus Pb equal to 18,600 and 688. So that is called 18.688 kilonewton per meter square. Okay. So one more thing, an inverted differential manometer is connected to two pipes A and B carrying water under pressure as shown in the figure. And the fluid in the manometer is oil of specific gravity 0.75. Determine, here you see there is a oil and there will be some differences A and B, and this one you can see they have mentioned 450, and this is center to center is 200, and here the axis is having good, but here some exceeding factor has happened. This we have to identify 0.75. So left limb, you see this is a left limb, it is having good, there is no excess. Pa minus rho 1 gh1. Pa minus rho 1 gh1. Pb minus rho 2 gh2. That means in a simple sense we will always make it equal. Pa minus so Pa like LHS equal to RHS, we can see Pa minus 1000 into 9.81 into 0.45. 0.45 is nothing but this one in a simple sense. That is also equal to Pb. Pb we are having two kinds. One is with respect to oil, one is with respect to with respect to water. So Pb minus 1000 into 9.18 into 450. You see, this is 450, and 750 is nothing but rho naught, that they have already mentioned. See, 0.75 is nothing but 750 into 9.81 into 0.2. So into 0.2, that is equal to, if you are solving you will get Pa minus Pb, the difference in the pressure is 1471.5 Newton per meter square. So once you cross check, See here, this is calculated. Left side 450 plus 200, that is equal to 650. Right side we have 450. So 650 minus 450, that is equal to 200. This 200 is also were treated as 0.2, 0.2. Now you can see summary of lectures. So discussed with respect to measurements in differential manometers and mechanical gauges, solved some problems involving mercury and oils, and analyzed the vacuum pressure using height differences, and used differential manometer to fluid pressure, and introduced inverted differential manometer with lighter fluids like oils to measure the pressure difference. Okay. If any queries, please mention in the comment section. I will reply. And thank you. We'll meet in next class.